How you guys? Welcome back to my YouTube channel. We're still under fluid mechanics, the flow in parallel pipes, the flow through parallel pipes, right? We have the question here is reaches for 3 pipes. We have 3 this time. 3 pipes, you see, 3 pipes of diameter D and 2D and 3D respectively. They tell us the diameter, right, respectively, are laid in parallel. So take note of this. Okay, they are laid in parallel. You're right. It's 3 pipes, isn't it? Three pipes are laid in parallel. Right, we have 3 pipes are laid in parallel. There are the 3 pipes. Connected water tank, right? Fine. The 3 pipes have the same length. That means they're exactly the same. They have the same length. They must have exactly the same length. Right. They have exactly the same length. See. That means the distance of this pipe from here, obvious throughout, the distance is the same. This is the length of the pipe, right? Which is the distance, which is the length, is the same. Its length did not tell us what length it is, but we know the length are the same throughout, isn't it? We have the same length and the same coefficient of friction. They have the same coefficient of friction. These pipes have the same F. It's equal. Right. Coefficient of friction of 1 must be equal coefficient of friction 2, coefficient of friction 3. Is the same throughout, which is, it is what we have been expecting. Supposed to have that. Right, then the smallest pipe discharge, they give us Q of the smallest charge, which is, remember this one is pipe 1, pipe 2, pipe 3. Then the diameter here is D will be D. Then the diameter here is 2D. The diameter of this one, of this last one, will be 3D. Obviously, the small one is D. It's like 1, 2, 3. 1 is smaller than 2. Then this will be, we'll have the Q for this pipe. That Q, they say it is 28 liters per second. Here we don't know. Yeah, we don't know the Q for Q1, we don't know. Q2 we don't know, and Q3 we don't know. They did not give us. Also, we don't know the velocities of this thing. V1, V2 we don't know. Okay, let us try and attack this question. They say now calculate the discharge through each of the 2 pipes. They want the discharge of these 2 pipes. Already we've given the first one. So we must attack that question. We must know we're dealing with what. There must be water discharge link here. This area shows that there's a flowing water. Right now, we apply what we know. Isn't it? Right. Should apply what we know. Fine. Right. I want you to check something. I want you to know something. This parallel pipe friction head lost head due to friction for pipe 1 must be equal to HF2. Remember now there are 3, must be equal also to HF3. There are 3 pipes there, isn't it? Since there are 3 pipes, we want Q, the discharge, to make our life easy. To make your life easy, if they want you to calculate the discharge, use this one. The formula of HF will say, this will can say, to make our life easier, we won't use the one that has velocity. We'll use this one, H1. Here we can say the one that says FL Q squared over 3D, right? Raised to the power 5. Use this one because we want this, and then there's no velocity. Just make your work easy. So we'll use this one. Let me just write here. HF1 must be equal to HF2 is equal to HF3. Right. We know the formula that we must use. Just is to state that we know that's all be equal. In other words, we can start by showing that, okay, we can start by this one and come with this one and this one. We can start say HF1 is equal to FL1 Q squared over 3 D1 raised to the power 5, right? But it's the same, remember, there must be things that must cancel here. If you can take it from, if we can show it from here, okay, if I can say FL1 Q squared over 3 D1 raised to the power 5 must be equal to that one. FL2 Q1 here, Q2 squared over 3D, right, 2 raised to the power 5 must be equal to FL3 Q3 squared over 3D3 raised to power 5. Right, it's what we are trying to say there. So since it's math, 3 and 3 must cancel. Right, these frictional, they are the same, they are the same, isn't it? So I'm trying to say that means if we cancel this, try to show that this will cancel. So that will not confuse ourselves. We can take it step by step. We can start by HF1. HF1 it's equal, take this, remember we've already cancelled this and this. Will you take only this stuff here, will be L1 Q1 squared over D. Yeah, remember D1, I'm just substituting over D1 raised to the power 5, isn't it? Then this will be equal to, do we have length 1? What is the length? We are not given. Are we given the length? We are not given the length. The length is the same. Okay? Since the length is the same, cancel the length also. Cancel the length. The lengths are the same. That means this will, we won't have length here. They are the same, isn't it? Cancel this, cancel. That means now we'll be left with something like this throughout. Cancel those ones, we'll have something like this. Cancel, we'll have something like this. Isn't it? Right. That means Q1 will take this, will be Q1 squared over D1 power 5. Right. Then do we have Q1? Yes, Q1 we have given this, we divide by 1000 to be in cubic meters per second. Divide by 1000, have 0.028 square this, divide by what is diameter 1 is D. Since you just write D raised to the power 5, isn't it? It's what we have, isn't it? So there's nothing you can do. This is HF1, this is D. What can we do? Nothing. Either way, you come say HF2 now. We are done with this one. Let's check HF2. Take this. Q squared over 2 D2 raised to the power 5. We don't know. We don't know Q2, isn't it? Would be Q squared. We don't know this one. Right. We don't know what it is. It's very right. So what we don't know that. Also, this will be over diameter 2 is here, is 2D. This will be 2D raised to the power 5, all of them. It's maths, you square all of that, right? Still we don't know, it's fine. What down here with 2 come with h of 3. HF3, take this, will be what? Q squared 3 over D3 raised to power 5. Q3 we don't know, will be Q3 squared. D3 here is 3D. You write 3D. Use raise this to the power 5. Right. This is what we have then. This is what we have. This is what we have. We are done with this, but now our aim is to calculate the discharge. We are done with this. Now we can equate this. Remember, we can come here, you return back F1. You can take it step by step. you can take, it's either you take, we know, remember F1, we already know. Advantage, equate, already you know, this one has one unknown, this they have two unknowns. Equate the one that has one unknown with the one which has two unknown. Also equate the one that has one unknown, equate with the corresponding that has two unknown. We cannot equate these ones, we cannot find nothing because two unknowns, right? So we can equate F1 or with F2 or F1 with F3. Either way, they are the same, all of them. But I'm trying to say you can equate HF1 with HF3 or HF2. It's up to you. How do you want to attack that? Right, you can consider HF1 or HF2. Okay, I can say HF2. I can take this at the time. Right, I can take this at the time. You see, HF1 and HF2. I can equate those ones. So, right here I can equate HF1 and HF2 because HF1 has two unknown, which is will make the lives to be easy, isn't it? Make the life to be easy. You equate, we have HF1, it's what is 0,028 squared over d raised to the power 5 is equal to, raise it to q squared over 2 over d 2 raised to the power 5. Isn't it? Is that what we have there? Right. That is what we have. Right. Let me not put D2 here, mad. Let it not be D. Remember, it's D. It's not D something, it's just D. It will be D. Yeah. There's no need. Here there is 2 here, man. D2 like this. So it will be 2D. All of these raised to the power 5. So mathematically, if you have something 2d raised to the power 5, this will be equal to, 2 raised to the power 5 multiplied by d raised to the power 5, right? So this you can replace this with 2 raised to the power 5 and d raised to the power 5. Mathematically, the denominator the same. This will cancel this, right? Then you'll cross multiply there. You will have 2 raised to the power 5 multiply to 0,028 squared is equal to q cubed squared, right? Punch the calculator there. You don't know your maths, but that's my math. If you punch them, punch the calculator, this will give you 0 multiply 2 raised to the power 5 multiplied by 0,028 squared. That will have 0,0251 q2 squared. Take the square root both sides. We'll have q2, you square root just take square root actually here, both sides. The square root will cancel with the squared. Then you punch this square root of 0, square root of 0, 0251 must give you what? That 0, 1, 5, 8, 4 cubic meters per second. You have Q2. You have Q2. Now let us calculate Q3. We can equate N. Remember, we can equate. Now we have this Q2. You can equate F2 and F3 or F1 and F3. It's up to you. What are you willing to take? What do you want to take? You can consider N of there. It's one and the same thing. We'll use the same step. Then let me erase here. Now we can consider HF1 is equal to HF3. HF1 we already know that is 0, 028. It's here 0, 0,028 raised to the power 2. It's power 2, isn't it? Over d raised to the power 5 must be equal to Q3. We already know Q3 there will be Q squared over Q3. FH3 is over 3D raised to the power 5. Remember, mathematical 3D raised to the power 5 is the same as that 3 raised to the power 5 multiplied by d raised to the power 5. It's in it. So we'll replace this with that. Will be 3 raised to the power 5 d raised to the power 5. Mathematically, this is the same. This is the same since it is multiplication. Then we'll have it 0, 0,028 raised to the power of 2 multiplied by this 3 raised to the power 5. Then we left it 3 square. 3 cubed. Get this squared. Take the square root both sides. Take the square root both sides. Then it this and this cancelled here. Take the square root both sides. This will cancel that. There we'll have Q3. Take the square root of 0, 0.025 squared multiplied by 3 to the power 5. If you punch your calculator, you're supposed to get that. Q3 is 0, 436 cubic meters per second. Right. Now we have them. We have all of them. Q1 we are given. We know that Q1 is 28 liters per second. Q2 is this. You multiply by 1000. You'll have, when you multiply that by 1000, you'll have 158,4 liters per second. Then Q3 multiply this by 1000, will be 436,5 liters per second. Then this is your stuff here. You're done with this question. You've just completed each right. Okay guys, thank you for your time. Do not forget to subscribe to my YouTube channel so that you'll be notified whenever I post a new video.